All right, so today we're going to take a look at dividing a decimal by a whole number. We're going to try and understand what's going on here and how are we supposed to go about it. We're going to take a look at two problems here. We have 1.5 divided by 3, so 1 and 5 tenths divided by 3, then 2.4 divided by 4, so 2 and 4 tenths divided by 4. So when I have 1.5 divided by 3, how am I going to do that? And with a decimal, the problem looks trickier, but it really isn't any harder. Now, first let's go through and think about this logically for a second. What if I'm looking at a problem here where, what am I really doing when I divide? Well, when you divide, there's really two ways of looking at it. You can look at it as saying how many times a number will go into another number. We could do 1.5 divided by 3, but 3 can't fit into 1.5. So that type of logical thinking for division doesn't work. Division also has another way of thinking about it, and that's to break something into a number of groups. 1.5 divided by 3 can be breaking 1.5 into 3 groups. That's how we're going to look at this. And we're going to look at 1.5 as money here, as $1.50. So right here I drew out $1.50 in dimes. Each one of these little circles here is 10 cents. So we have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 cents, which is $1, and 10, 20, 30, 40, 50 more cents. Well, if I'm going to break up this $1.50 into 3 groups, I actually kind of see how that might be able to happen kind of evenly. It looks like I have 3 equal groups right there. So if I break it into 3 groups, how much is in each group? Well, it's 1, 2, 3, 4, 5, which is 50 cents. So it looks like $1.50 divided by 3 would give us 50 cents. Now, if I think about this logically, I don't really just have to break this down into dimes. I could also think of it as quarters. I know $1.50 would take me 6 quarters to get there, and if 6 divided by 3 would give me 2 quarters, which would also be 50 cents. So I could look at this a couple different ways if I wanted to go with, those 25-cent pieces and have each of these be 25 cents, having these nice pretty quarters. And I break it up into 3. Each group of 3 would have 50 cents still. So however I look at it, I got 50 cents. So how do I get this 50 cents though using math? Because we're not always going to be able to use coins. So what we have to realize is we're going to divide this just like we normally would. So I'm going to have, let me write this again. 1.5 divided by 3. Now, when we're doing this and when we're dividing by a whole number and just making it into groups, I draw a line right down there, right down our decimal point. That makes it easy for me to keep track of. 3 goes into 1 0 times, doesn't work at all. Okay, but 3 goes into 15 5 times. 5 times 3 is 15. Subtract, I get 0. Look at that, I'm done. And I end up getting, again, 0.5. 0 and 5 tenths. 0 or 50 cents if you want to think about it as money, or 0.5 is 1/2. We could look at that number in several different ways, but we have 5 tenths there. And it's not too bad. We're able to divide it straight out. Now let's take a look at this one, 2.4 divided by 4. Let's try it and see what it looks like. 2.4 divided by 4 and see what we get. Draw my line down the decimal point. 4 cannot go into 2 at all. 4 can go into 24 6 times. 6 times 4 is 24. Subtract and I get 0. So it looks like this is going to be 0.6 or 60 cents or 6 tenths, however we're looking at it. Well, if I'm thinking about this in terms of 60 cents, right here I drew out $1, $2, and 40 cents of dimes. So if 2.4 divided by 4 gives me 60 cents, or 0.6, that means I should be able to break up these dimes into 4 groups of 6 tenths. So here's one group of 6 tenths, 6 dimes. Here's another group of 6/10. Dimes, work, by the way, work really good whenever you're trying to think about numbers with decimals, especially when you have a tenths place, because dimes are 1/10 of a dollar. So they're a good way of thinking about that. So right here I have 6/10. Here I have 6/10. Let's see, 1, 2, 3, 4, 5, 6. There I have 6/10. Here I have 6/10. I could break up 2.4 into 4 groups of 6/10. So 2.4 divided by 4 is 6/10. So it works logically. So we can think about logically using dimes, counting out those tenths of a dollar, and use that to help us figure it out. Or we could just use the algorithm, and either one will work just fine depending on what we want. So even if I get a far more complicated problem like say 2.91 divided by 3, that would be a tricky looking problem, right? And with 2.91, I'm not going to want to draw out pictures. It's like, that could be 91 cents. I could draw out 91 pennies, but really, do we want to do that? No, that'd be 291 pennies. We don't want to do that at all. But I can go in here and say 3 can't fit into 2. But 3 can fit into 29 9 times. 9 times 3 is 27. Subtract and get 2. Bring down the 1. And 3 goes into 21 7 times. 7 times 3 is 21. Subtract and I get 0. So if I have $2.91 and I break it into 3 groups, I end up getting 97 cents in each group. There we go. Can we think about this logically and see if that makes sense? Well, let's see. $2.91, that's close to $3, right? So if I broke up $3 into 3 groups, I'd have close to $1. Is 97 cents close to $1? Yeah, it's pretty close, only 3 cents off. So we could still think logically about to kind of estimate and check our work and see how we're doing, but that's all we got to do. We're able to go through, get it figured out, and be able to divide. Just keep track of where that decimal place is. I like to draw that line all the way through where that decimal is so I know where to put my decimal place in my answer and get that whole number on the left and the decimal on the right. Give it a shot, do your best, and you're going to do great.